Now the next topic that we are taking is the properties of multiplication of integers. So what are the various properties? There are some common properties that we have already done, like closure property, commutative property, associative property. They are also applicable for integers or not. Let us check them. So the first property is closure property of under multiplication for integers. Now again, it is just similar as we have done previously also. Like if the product of two integers is also an integer, then we say that if a and b are any two integers, then what is their product? The product is a into b, that is a multiplied by b. So the product will also be an integer. For example, if we take minus 20 times minus 5, the result is 100. So minus 20 is also an integer, minus 5 is also an integer, and 100, the product, is also an integer. Similarly, we can have some more examples like minus 15 times 17, a negative integer and a positive integer. The result is going to be a negative integer, and the product, final product, that is minus 255. This is also an integer. So yes, is it true for all the values? Yes. Whenever you take any two integers, the product will always be an integer. Even you can try by taking 0 as one of the integer. Like if you take 0 multiplied by any number, the result will be 0. And we know that 0 is also an integer. So here we can see minus 30 times 12, 360, again an integer. Minus 15 times minus 20, that is 300. Again the product is an integer. So whichever integer you take, the product will always remain an integer. So this is about the closure property of integer. The next property that we take here is commutative property of multiplication. As we have done for addition, it stated that a plus b will be equal to b plus a. Now when we are talking about commutative property of multiplication, it reflects that a times b will be equal to b times a. Here the two numbers will be multiplied by each other. And let us check, is it true or not? So here if we take an example like minus 3 times minus 4. So yes, you know, if I multiply this by this or if I change their positions, the result will always be same. Since both of them are negative, so the result will be 12. We have to simply multiply 3 by 4. So 3 times 4 is 12, and since both are negative, the result will be positive. Whenever we multiply a negative sign by a negative sign, the result is going to be a positive number or a positive integer. Second example, if we take minus 6 times 5, it shows either if I take 5 previously and then I write minus 6, that is if I multiply 5 by minus 6 or minus 6 by 5, the result is going to be minus 30. Since we have to simply multiply 6 times 5, that is 30, and one is negative and other is a positive integer. So a negative multiplied by a positive integer, the result will be negative, because here the two opposite signs are getting multiplied. One more example we may see, like 5 times minus 9. Either you can write it as minus 9 times 5 also, but here the result is going to be the same, that is minus 45. So here it implies that you can multiply any integer in any order, like 2 multiplied by 3 is also 6 and 3 multiplied by 2 is also 6. So we can relate it with commutative property of for addition also. Like a plus b was equal to b plus a, and similarly a times b is also equal to b times a. Now the next property is multiplication by 0. Whenever we have any integer a and if we multiply it by 0, the result is going to be 0. You know that already. So if you multiply a by 0 or 0 by a, the result is going to be 0. For example, a may be here a negative or a positive integer, irrespective of the sign we will take. So minus 6 times 0 is also 0, and 0 times minus 32 or 0 times minus 22, the result is going to be 0 always. Next property is multiplicative identity. As we have done in additive identity, it says basically the identity of a number should not change if we add something, right? So 0 was the number, if it is added to any number, it will not change the identity. Similarly, what is that number? If you multiply that number by any number, the number should not change. For example, if I am taking a number a By what should I multiply a so that the result I should get again as a? So right, you are correct. The result will be 1. If I multiply a by 1 or 1 by a, the result is going to be a in this case. So which number didn't change the identity of a? That is the number 1 when it is multiplied. If I ask about the additive identity, the result will be 0. Here, let's see some examples. Minus 6 times 1. Whatever number you are taking, if you are multiplying by 1, you are getting the same result and you know it very clearly. Whether it is a negative number or it may be any positive number also. But yes, 0 is an exception because 0 multiplied by any number will give you the result as 0, and that is the property of 0, that is multiplication by 0, right? So any number multiplied by 1 will give you the number except the integer 0. 0 is an exception in this case. Now, the next property that we'll take is multiplicative property of minus 1. This is a very important property which you will be using in the chapter algebraic expressions also, when you will be dealing with the factors also. So understand it carefully. Like it means for an integer, we have a times minus 1. Whenever a number is multiplied by negative 1, what value you'll get? You'll simply get the same number, but the sign will be opposite. For example, here it is a times minus 1, the result will be minus a. Or if you multiply minus 1 by the number a, again the result will be minus a. For example, if I multiply minus 6 by minus 1, simply I multiply 6 ones are 6 and minus into minus is plus. Whenever the same signs are multiplied, we get the positive sign, always remember. So in simple we can say, since we multiplied minus 6 by minus 1, the result is positive 6. Here I am multiplying minus 32 by minus 1, the result will be positive 32. So here 22 is multiplied by minus 1, the result will be minus 22. So we simply change the sign of the number which is getting multiplied by minus 1. Now moving on to the next part, that is again a very important and a closely related property, that is the associative property for addition. Again related with addition, when 3 numbers were added in any order you can add them. So same thing is applicable for multiplication also. That means if a, b and c are 3 integers, then a multiplied by b multiplied by c is equal to a multiply b multiply c. Here the position of bracket is important. Like you may multiply first a and b, then you can multiply the result by c, or you can multiply b and c first and then you can multiply the result by a. Let us understand with an example. Suppose if I give you 3 times minus 2 times 4. So what you get here? First we will multiply this because this is a big bracket. So we will solve the big bracket first of all. So 3 times minus 2 will be 3 2s are 6 with a negative sign because there is only one negative sign getting multiplied. Odd number of negative signs are here. So minus 6 times 4. And what is minus 6 times 4? The result is minus 24. Similarly, if I now make a pair of minus 2 and 4 like this. So 3 times I'll first multiply minus 2 by the number 4. So what I'll get here is minus 8. And then I'll multiply 3 by minus 8 to get the result as minus 24. So in whichever manner you can make a group, right? So 3 numbers can be multiplied in any order. You may even multiply 3 by 4. Then you'll get 3 4s are 12 and 12 times minus 2. Again you'll get the same result as minus 24. So irrespective of the group which you have made, the result will be same always. Let us now take one more example based on associative property. Suppose if we multiply minus 7 by minus 6 and then multiply the result by 4. So what is the result? First we multiply 7 times 6, that is minus 42, and then we multiply it by 4. So 42 times 4, you get the result as 168 and it will be negative 168. Similarly, what if I make a pair, I change the pair from 7 and minus 6 to the number minus 6 and 4. Then what will be the result? I'll first multiply minus 6 and 4. So the result is minus 24 in this case. Now 7 times minus 24, what result you will get? Again you will get the same result, minus 168. So I think this associative property of multiplication is clear to you all now. That shows basically the grouping can be, you can make a different groups over here. You can relate, you can make a group of first or the second, second or third, first or third, or even if there are more numbers, like more number of integers which are getting multiplied, you can make any group of any 2 or any 3, which helps you in getting your calculations more easier. We'll do some questions based on that also. Now, we'll start with the next property, that is distributive property. It is again applicable for integers, but it is a bit different from commutative and associative property. In commutative property for addition, remember all the numbers were getting added. In associative property for addition, all the numbers were getting added. Similarly, in commutative property for addition, like multiplication of the integers also we have seen the commutative property, a times b is equal to b times a. That again shows numbers can be multiplied in any order only, right? That means the numbers were only multiplying. Similarly, in associative property, the numbers again were getting multiplied. That means we were doing only one operation in commutative and associative property. But when we deal with the distributive property, it is not a single operation which is going on. Here, distributive property is divided into two things. That is, it is either distributive over addition or it is distributive over subtraction. So, let's be more precise in this case. The multiplication of integers is distributive over addition and subtraction. What do you understand by this? We can relate it. Like if a, b and c are 3 integers, then we can say, if first I'll deal with distributive property over addition, then it says that a is multiplied by addition, that is sum of 2 integers. Then what happens if a is a integer which is getting multiplied by the sum of 2 integers b and c? Then what happens in this case? A is getting distributed over b and a will get distribute over c. Now distribute means a is getting multiplied by b as well and it will get multiplied by c also. So here we'll first get a times b and then we get a times c, and both the products will get added. Why they are getting added here? Because it is distributive over addition. I'll relate a story with this. You can see, suppose if there is a birthday, it's A's birthday. A is a person, okay, and it is A's birthday, and in the class there is A's brother as well as cousin also. So you can relate it like this, that B stands for say brother and C stands for the cousin. So what happens? A will go to the class and then what happen? A will distribute the chocolate to brother also and to cousin also. Very simple. So A will be distributed over B as well as by C in the class itself, right? So we have a class of A and B getting multiplied and the class of A and C also getting multiplied. So you can relate it like this. But what if they are getting subtracted? So again, A will distribute the chocolate, right? But the thing is, in place of addition, it will change to subtraction. Just this is the only difference. And actually, we do this in our daily life also. Suppose that you went to the chocolate, you went to a market to get the chocolate. Then what happens? Suppose if one chocolate cost rupees 10 and the another chocolate cost rupees 7. Okay. And now suppose that you want 5 such chocolates. So what you do? You go to the market, you go to the shop, and then what do you say? Ki I want 5 chocolates of rupees 10 and 5 chocolates of rupees 7. Okay. So what will be the cost of the total chocolates that you have purchased? Simply you will do, since there are 5 chocolates of 10 rupees. So 5 chocolates of 10 rupees will cost rupees 50. Similarly, 5 chocolates of 7 rupees will cost rupees 35. Now, what is the total amount that you will give to the shopkeeper? The total amount given will be 85 rupees. Correct? What you can do one more? Because you want to make a packet of it. So what you can also do is, you want to purchase a set of chocolates which cost rupees 10 and 7, and you want 5 such packets. Like if you want to give these 5 chocolates of 10 rupees and 7 rupees each to 5 of your friends. Okay. So to one student or to one of your friend, you will give the amount that is 10 plus 7, that is 17 rupees. It is distributed in how many friends? So you want to distribute it to 5 friends. So you will multiply here 17 by 5 and you will again get the result as 85. Both the methods are correct. And actually what you have done here is distributive property only. Here you multiplied 5 by 10 and 5 by 7 to get 5 by 10 and 5 times 7. So we can say that both these things are equal. That means they are following distributive property over addition here. So here I think distributive property over addition is clear to you with this example. Now the next property that we do is distributive property over subtraction. It is just relatable. The only difference is of sign. Plus changes to minus. Here also plus change to minus. Rest things remains the same. That is, A is multiplied by B and A is multiplied by C. Similarly, here also A is multiplied by B and A is multiplied by C. We can see certain examples of it. For example, if minus 2 is multiplied by 3 plus 5, how can we do this? We can first do 3 plus 5. That is it. This is a general procedure that we follow using the BODMAS rule. That minus 2 is multiplied by 8, the result you will get is minus 16. If an example is given minus 2 into 3 minus 5, then how do we do? We simply do this, solve this thing. 3 minus 5, that is minus 2, and minus 2 times minus 2, the result is 4. This is a simple method that we used to do till now. But can we apply distributive property to them also? Yes. How can we do this? Look here. Now, this is one time. So, if I apply distributive property to this, I should multiply minus 2 by 3, and I should multiply minus 2 by 5 also, right? So, let me first find the product. The product is minus 6, and here the second product is minus 10. Now, I have to add these two. That shows I'll do minus 6 plus minus 10. Both the negative numbers are getting added here. Now, if they are adding, that shows we have to simply add the integers, because here they are of same sign. Whenever they are of same sign, we add the integer. So here 6 plus 10 gives you 16, and since they both are negative in sign, so the final result will also be negative, because here they are not getting multiplied. Remember, if they get multiplied here, then the final sign will be positive, because same signs when multiplied give you the result as positive, but same signs when added, you will get the same sign always. Similarly, the next thing here, we can relate here that this part is equal to this, because both the results are same. That means distributive property is applicable here also. Now, the next example here is for minus 4 times minus 2 minus 7. Now, this is distributive over subtraction. So, here what can be done? We simply solve this, we get minus 9. So, minus 4 times minus 9 is 36, because here both the negative signs are getting multiplied, and when they get multiplied, the result is positive. The final sign is positive, and we simply multiply the integers. Now, apply distributive property here. So, minus 4 is multiplied by minus 2, and minus 4 is multiplied by 7. And what is the sign here? Minus. It will be between the two brackets. Now, remember here that you will not multiply this minus 7. So, what you are multiplying here by minus 4 is only the number 7 and not minus 7. Remember, minus sign whatever is here will remain in between the two brackets, right? So you can relate it like this, that minus 4 times minus 2 is 8, then minus, and when you multiply these two you get minus 28, and then again open the bracket. So if there is a minus sign before a bracket, what we have already discussed, sign of the numbers inside the bracket will be changed. You will write the opposite. Or you can relate it like subtracting a negative integer is same as adding the integer. Remember, so minus here is getting multiplied by minus. So we can say they are getting multiplied. So whenever the same signs are multiplied, the result is positive. So 8 plus 28 and the result is 36. Now we can conclude here that this part is equal to this part, and both the answers are equal to 36 in this case. So again we have applied distributive property here. Now here are some questions for you to try. You can try it on your own and you'll relate that if you find this result and they should be equal from the left hand side, you solve separately, solve the right hand side separately, and then you'll relate that both the results are equal. Now let's proceed further. The next topic here is how can we use these properties to make our multiplications more easier. What is the actual use of these property? There should be certain use. Otherwise, there is no, if these properties are not required by us, then why they were introduced? These properties are actually introduced to make our work, to make our calculations more easy. Because see, if this is our question given to you, like minus 25 is multiplied by 37 times 4, then how you will do? You may first multiply minus 25 by 37, then find the result, and then you multiply the final result by 4 to get one more thing, right? But in this way, like minus 25 times 37, you will get minus 925, then multiplied by 4 to get minus 3700. A bit lengthy. Let us make it more simple. By using which property we can use here? Can we use distributive property here? No, because all the numbers are getting multiplied here. So we can use associative property here. So using that property, we can simply make a group. Let us rearrange, because we can use commutative property as well as associative. See, here I have interchanged the positions. That means I have used commutative property here, because 37 times 4 is same as 4 times 37. And now I am making a group of 25 and 4. First I am multiplying negative 25 by 4. The result is 100, because very simple, we know 25 times 4 is 100. So minus 100 and 100 times 37 is minus 3700. So isn't the second method more easy for us, right? So properties helps our calculations to get more easily done. So we can use these properties, associative, distributive property, so that we can reduce the calculation work. We can even do it mentally as well. 25 times 4 is 100, and any number multiplied by 100, you just put 2 zeros. But to find 27 times 37, 25 times 37, you need to do by the column method here. So let's see one more example based on this, and it is 16 times 12. Very simple. If you know the table of 16, if you know the table of 12, very easy. But can we use a property here? Yes. And using this simple question, you can easily do all the lengthy questions also. So just see, I can split 12 as 10 plus 2. And then I can write 16 times 12 as 16 times 10 plus 2. Fine. Now which property can be used here for in 16 times 10 plus 2? Just note here that there are two different operations going on. One is multiplied and one is addition. In the class, that means in the bracket, the numbers are getting added. So we have to use distributive property over addition. So here 16 will be multiplied by 10 and 16 is multiplied by 2. Now 16 times 10 is 160 and 16 times 2 is 32. That you already know. The result is 192. Right? So without actually doing the multiplication by column method, we have done the multiplication using a distributive property. Now you may ask, can we split 16 also? So yes, you can split 16 as well. You can write 16 as 10 plus 6 and then multiply it by 2. Let me do it for you here. If I do 10 plus 6 times 12, then again what I have to do is I'll multiply 12 by 10. So 10 times 12 and 12 is also multiplied by 6. So in the second bracket, let me multiply 12 by 6. And finally, these two brackets will be added here. So I am adding these two. Now 12 times 10 is 120 plus 12 times 6 is 72 and the result you get is 192. Right? So just check, you are getting the same results. So you may split 16 or you may split 12 also. The result is going to be same. Now, the next thing here that we'll discuss is one more example with a negative number. What if a number is negative like minus 23 times 48? So here, I can split 48 as 50 minus 2 also, right? We can also split as 40 plus 8 or we can split as 50 minus 2. Both the ways it will be correct. Or even you can split minus 23, it depends. Now, it's easy for me to split it like this and to write minus 23 times 50, then minus 23 times 2 and the numbers will be subtracted here. So, I can multiply 23 times 5 and just put a 0 and 23 times 2 is 46. But since negative is multiplied by positive, the result here is negative. And similarly, negative times positive is negative and this minus is as it is here. So, now what we have to do? Since it is minus 46 and a minus sign is before this, so sign of the second bracket will change. That means minus 46 will now become plus 46. And now we have 1150 with a negative sign plus 46. Now they are of opposite signs. That shows we have to subtract the numbers because they are now opposite in sign. So if I subtract 46 from this number, I'll get 1104. And here this number is greater, so I put the sign of the greater number. That is, the result is 1104. Let us now take one more example over here. If both the numbers are negative, then what happens? Minus 35 is multiplied by minus 98. Now let me split one number. If I can split minus 98 as minus 100 plus 2, very important thing. We will simply not write as 100 minus 2. This is negative number. So here we need to put one more thing. How you have written this thing? It is minus 98, right? So you can simply write minus and write 98 as 100 minus 2. Now, since there is a minus sign before the bracket, what happens? If it opens, it becomes minus 100 and the sign of minus 2 will now become plus 2. So how can you write minus 98 as minus 100 plus 2, which is written here in this bracket? Okay, I hope this is also clear how you can write this thing. So minus 98 is written in this way. Now apply the distributive property. So multiply minus 35 by minus 100 and minus 35 by 2 and then put a positive sign, that is plus sign, in between the two brackets like this. Multiply these two and multiply the next two numbers, that is minus 70. Now, since there is a plus sign before the bracket, so the number sign which is there in the bracket will not change, it will remain same. It gets changed only if there is a minus sign before the bracket. Okay, or in other words, we can also say that here these two signs are getting multiplied. They are opposite signs. Whenever opposite signs multiply, you get the negative sign here. So, if I open the bracket, I'll get the result as 3500 minus 70, which gives me 3430 as the final answer. So, I hope this question is also clear. If a positive number is multiplied by negative, or both the negative numbers are multiplied, or both the positive are multiplied. Let us now move on to the next part. With one more example, let us go with the opposite of it. Now, if this is the question given, 52 times minus 8 plus minus 52 times 2. Now, this is a very important again type of question. Here we can see, we can apply distributive property from right hand side to left hand side also. right? As we write a multiplied by b plus c is equal to a times b plus a times c. Let me introduce here. This is a times b plus a times c. But are a same in both the cases? Here we are having a positive 42 and here we are having a negative 52. So how can we say that they both are same? They are not same. But now the question arises, can we make them same? Let's see right now with few simple example here. Suppose if I give you a number minus 2 times 3. What is the answer to this question? You say that we multiplied 2 by 3 and since one negative sign, so it is minus 6. Now let me make this 2 as positive, and if I make this 3 as negative, then what is the answer? Again the answer is minus 6. That means if there is one negative sign only and two numbers here are getting multiplied, I can also write this as minus of 2 times 3, right? That shows if there is a minus sign with a product of integer, the minus sign can be with any of the integer. It may be with 2 here in this example, or it may go with 3 also. The result will remain same. It will not go with both the sign, both these integer. Remember, you may either write minus 2 times 3 or you may write it as 2 times minus 3. Same is here. So we can apply this part over here and we can shift this minus sign to this positive 2, right? So minus 52 times 2 can also be written as 52 times 2. This minus can be written as minus 2. It can go with the next number. So now let me write here 52 times minus 8 as it is, and this can be now written as 52 times minus 2. And now you can see 52 and 52 is common. It is repeated with, it is in the first product also and it is in the second product also. Now can we relate it with a times b plus a times c? We have the distributive property. So if we relate it here, then we can write it as a times b plus c in this case. Just see, if I am writing here as a times b plus a times c, I can also relate it like a times b plus c. That shows from these two product, I am having a number common which is a. A is common from these two, so I can take this a common out from the bracket and then I can simply write b here. What is remaining from this is c and a plus sign in between. So I think this question is relatable now with the property over here. So from these two we have taken 52 common. So what is remaining from the first is minus 8. From what is remaining from the second product is minus 2. And positive sign from between these two is as it is copied down. Now let me simplify this part very easily. I can say 52 times minus 8 plus minus 2. Both are negative signs. They are getting added here. So we simply add the integers and we put the same sign. They are friends, right? Minus 8 and minus 2. Both are negative. So we get minus 10, and 52 times minus 10, the result is minus 520. So isn't it that distributive property has made our calculation more easier? Rather, if I multiply first 52 by 8, then 52 by 2 and then solve it, this is much more easier method. One more thing in this question, in this part, you can try with these questions here like minus 49 times 18, minus 25 times minus 31 and this way. So just relate these questions with the distributive property and with the content that we have already discussed.